Hi EFR, hi EFR 515 students. This is dealing with Chapter 9, Introduction to the T-Statistic in this chapter. Now, we did a t-test last time to introduce hypothesis testing, and here we discuss T-statistics more. They start out talking about the Z and then dealing with the T-distribution and talking about degrees of freedom associated with that. So essentially a T is like a Z, except it has more dispersed or wider tails to adjust for the sampling distributions that exist in nature. So we continue on to talk about the idea of the hypothesis test and the effects, and talk about different types of t-tests. And specifically, we're going to do a one sample t-test. In the previous chapter, as an example of hypothesis testing, we did a two samples t-test, which we'll revisit and eventually do a paired sample t-test. But specifically here, we're going to talk about a one sample t-test. So if you go ahead and look at the exercise 9, Introduction to t-tests, I ask you to enter the data, enter the below data into SPSS, conduct a directional one sample t-test to see if the population grades are greater than 80. Write up your results in APA format. Use a type 1 error rate of 0.05 to evaluate your test. Now, in the non-directional test, for example, the grades could be higher or lower than 80. It wouldn't matter. But directional test, what we're specifically interested to know, say these are test scores of students down here, where there was a 78, a 95, a 74, an 80, an 83, and 85. What we'd like to be able to know or argue is that the population scores for these students are greater than 80. Okay, and now key aspect is population. Now if we calculate the means of these, we're probably going to get a value that's greater than 80. But that's the sample, and with sampling variation, what we want to know is in the population, does it exist? Now I've asked you to test it with a type 1 error rate of 0.05. So indeed, if we do reject the null, meaning that the scores are 80 or below, and decide that the null being the scores are 80 or below, and that they're larger than 80, we'd think the population of students are scoring 80 and above 80. So let's go ahead and conduct this test. So here's our data, here's our scores, and the first one is 78. So I'm going to go over to variable view in SPSS. So I'm going to click on that, and I'm going to type in the name of the variable, which is scores. And then I'm going to go to data view and then type in the data. So we have score of 78, 95, 74, 80, 83, and 85. Now to conduct this test, I'm going to go up to Analyze, Compare Means, One Sample t-test. Okay, the test variable here, we just have one. It's scores. I'm going to bump that over. And I already have it. The test value here is 80. Right? We want to know if the scores are greater than 80. By default, the SPSS program is going to run a two-sample t-test, or a two non-directional, a two-tailed t-test. So we're going to go ahead and then just paste this. I'll go to my syntax window. I'm going to click my left mouse button and hold it, drag across, press the green triangle up here for run selection. Okay, and then we have our output here out. So let's go ahead and bring this into Word. So I'm just going to copy this. So I click on the sample statistics, copy, and then I'll bring it over to Word. Go ahead and paste it in there. And now I think my next table is probably small enough where I can just paste it in to my Word document. Yeah, I'm not overrunning the page, so that's fine. And finally, I'm going to go get my syntax because I'm asking you to do that. Copy that syntax over. Okay, so now I have the output of the test here. And I'm going to go ahead and look at this analysis. the first thing we see is, what is the mean scores of the test? Well, our mean scores are 82.6667, or if you round it, it'd be 82.7. So the mean test score is 80.7. Okay, now we want to know, though, is that difference large enough where we conclude that the actual population test scores are greater than 80? To evaluate that, we're going to look at our test statistics here. Now, our test value was 80, and so here is our t-value, 0.911. Our degrees of freedom is 5. Sig two-tailed is 0.404. The mean difference was, the difference from 80 was 2.66. And then we have the 95% confidence interval around that difference. Okay, so because if we were doing a two-tailed, this value right here, the 0.404, would be our significance level, or p-value, that we would compare against our type 1 error rate of 0.05. In this case, it is larger than 0.05. But because we did a one-tailed test, or a directional test, we have to do two things. First, did it go in the right direction? Meaning, is the mean here, the sample mean, greater than 80? So we see our value of 80 here, that our sample mean is 82.7. So indeed, it did go in the right direction. I'm sorry, the mean was 82.7, not 80.7. And so it did go in the right direction. If the mean had been 78, well, then we failed to reject the null, and we're done. We just failed to reject. But here it did go in the right direction, so it is greater than. Now, is that statistically significant? In order to evaluate this, we need to now divide the two-tailed value here of 0.404 divided by 2. Okay. So if I come in here and if I take 0.404 divided by 2, we end up with 0.202. Okay, so now that's my p. So p equals 0.202. So the mean is 82.7, which is greater than 80. So that's my first step. And then the p is 0.002. Now, my question is this p less than my type 1 error rate that I've designated for the test? And that value I designated as 0.05. So, and as we obviously see, it's greater than 0.05. So now we fail to reject the null, and we don't have any evidence either way that the true scores, the population scores, are greater than 80. So now I'm going to go ahead and write the APA for this, and that's a t-test with, I'm getting the t right here. Its value is 0.911. I'm sorry, the degrees of freedom are 5. So I'm going to get 5 equals then its value. The t's value then is 0.911, comma, and then p is greater than 0.05. And that's our APA test. So we've just done a one-tailed t-test, trying to decide if the population scores were greater than 80. Our sample mean was 82.7. And because we're doing a two-tailed test and the mean went in the right direction, we divided the sig two-tailed value, or the p-value, or the significance level, by 2. And we ended up with 0.202, but that was still greater than our type 1 error rate level, which was 0.05. So we said p greater than 0.05. So we failed to reject the null, and that's how we'd write it up. The score was 82.7, but it was not statistically significant. So go ahead and run that one-tailed test, that one sample directional test, and go ahead and upload it for exercise 9. Thank you.